Precision rifle shooting, whether for hunting, competition, military or law enforcement, or just recreation, truly defines a zenith in a marksman's capability and the state-of-the-art in weapons development.
Today's precision shooter has the weapons and equipment at their disposal to engage targets at extreme ranges. However, if you don't utilize the fundamentals and don't have your weapon set up properly, each time you pull that trigger, you're just creating expensive noise.
While Travis and I have been teaching more dynamic weapon manipulation and tactics, precision rifle is an area in which we defer to an expert.
We're in the Panhandle of Texas at Accuracy First Training Facility to work with who we believe is a top precision rifle instructor in the world. His techniques, principles, and proprietary methods are utilized by all branches of the armed service, including sniper schoolhouse instructors and special operations groups around the world.
Todd's teachings are so revolutionary that we can't even expose much of what's being taught to the military.
But we'll assure you what you're about to see in this training series will amaze you and possibly redefine the standards of what is possible in the precision rifle community.
Long range is really easy. All you have to do is apply the fundamentals. Everything works out for itself. We're not trying to change the world. We're just trying to question everything.
Hey Todd, thanks for having us out. Man, this is a truly amazing facility. I think I can speak for Steve, Mike, and Chris and myself. You know, coming from a more dynamic style of shooting and the speed templates that we have, I think we're about to gain a really big appreciation for the true art of accuracy dynamics.
I know for us, Todd, with a lot of the people that we teach, fundamentals are extremely important, and people get wrapped around basic and advanced as terms and kind of fail to realize a lot of times what makes an advanced shooter is the understanding of the basic fundamentals done over and over and being very, very specific and methodical about that. So I would imagine it's going to relate here more than ever.
Yeah, really, more than anything, it's basic fundamentals is what makes you high speed. And the more you understand the fundamentals and how to apply them, the further you can go out, the faster you can shoot. I've been shooting scoped rifles since I was 6 years old, so I thought I was actually a pretty good shooter for a lot of years. I'd shot deer at 800 meters, antelope at 700 meters. But until I started shooting out 2000, I finally realized I didn't know anything, and I had to completely retrain myself, which was how do I lay back behind the gun? How do I actually apply pressures to the weapon system? So that's what we're going to talk about today. Basic fundamentals, basic techniques to apply everything together to give us that precision that we need at further distances.
Well, that's what we really love about your program is it's just seeing some of the very basic fundamental things that you show makes me really go, oh my God, why didn't I know this 10 years ago? You know, and specifically in combat operations for myself, it's kind of like it's just all common sense, really.
Yeah, well, what we're really trying to do in the long range world right now is trying to make this where long range is easy. All right, it doesn't have to be hard. The math doesn't have to be hard. A lot of people are a little bit scared of it because they don't understand it. Again, it's kind of like the fundamentals. Really what we're trying to do in changing a lot of the formulas that we're using and all is to really work and make the math really simple. There's no reason to make it hard. So we're trying to get it to where everybody can do it, and it's really not that hard of a deal.
I'm definitely excited to find out.
All right, that sounds good. Let's get our guns and get on the line. All right, guys, what we have in front of us today is an MSR. This is set up in the 300 Win Mag version. In about 3.5 minutes, we could actually swap it over and turn it to 338 Lapua. All right, this is a 5 to 25 scope, has a locking turrets on it. It's a really nice scope. And guys, for accuracy, this is one of the most important things you can have. All right, you really need a good set of scope rings. A lot of people that aren't familiar with levers aren't real comfortable with them, but the way the camming system actually works, I've actually seen it locked in a Picatinny rail, and once you set it on the rail and you're looking with the scope camera and it's already locked on, all right, when you actually start moving those levers, you'll see that crosshair come right back down to the same point every time. Now we've shot them on and off, taking them off, shoot one shot, putting them back on, take one shot, take them off, put it back on, take a shot, and did it for 100 shots, all right? In that 100 shot process, it still maintained the MOA of what the gun could actually shoot, so we saw no impact shift. And I shoot them on all my guns. I think they're very important to have a really good, accurate set of rings. One of the biggest problems that I deal with a lot of the shooters that I train is parallax. A lot of people really don't understand parallax. We're type A personalities, all right? So we make things happen most of our life. Well, the problem with that is a lot of times it may not be perfect, but we're trying to make it happen and get through it. So that's one of the initial things that we'll actually set up. After we get the eye relief, we'll actually set up and work on scope parallax. Like I said earlier, you know, I had made shots out to, you know, 700-800 yards on deer and antelope, and I was really getting away with a lot of stuff because I really didn't know what I was doing. I was actually getting lucky. And, you know, even though most of the time we don't shoot at the extended ranges to where our arrows start showing up. You know, a lot of people shoot 300, 400, 500 meters, and really that's not long range shooting. Long range shooting, most of the time, our weapons are certainly more capable of that. You know, we take 308s and push them out to a mile on 16-inch plates. So they're very capable. The caliber is capable. As long as we do our fundamentals properly, that's where you're going to start seeing the accuracy come in. So what we're going to actually show you now is the things that I learned when I started shooting out to 2 grand with 338s and really kind of working the precision piece, what I had to do to retrain myself actually how to shoot out to that distance. And then we're going to get Steve on the gun, going to get him set up, show him eye relief, and then scope parallax. First thing I want you to do is line up directly behind the weapon system. So, you know, it's coming right underneath inside your knee. When you lay down on the gun here, you're going to use the rear bag. I don't want you to have pulse on the weapon system, all right? So that means I don't want you to use this hook, all right, because that's applying pulse. I want you to actually utilize the rear bag for your aiming, all right? You don't want a lot of heavy cheek pressure on. I want you to actually lay up here and like you're fixing to go to sleep. That's how much pressure I want on the cheek pad, all right? Then, guys, the way I teach most of my guys that I train, we only grip the gun when we're shooting at close ranges, all right? So if I need to actually watch where my bullet's actually hitting at close ranges to where I can't use my normal precision grip, we'll actually go ahead and grip the weapon system. I never wrap my thumb around the backside unless I'm shooting something like an SR.
And just out of curiosity, why is that? Why would you not run your thumb around that grip? Because that's what most people do.
Yeah, it's sympathetic movement. I found that when I was shooting out to 2 grand, we had an 8-foot piece of sheetrock. And when I would wrap my hand, the sympathetic movement as I pulled my trigger finger, my thumb would actually collapse with it a little bit. Okay. And as I did that, I would have some shots on target and some shot would completely miss 8-foot sheetrock.
So there's some inconsistencies in there with what your hand's doing.
Absolutely. And we do the same thing with the palm of our hand. So a lot of times the first thing that you do when you line up your scope, you're going to make sure that your scope is level on target, all right? Because any cant in there will throw the bullet off in that direction of the cant. So a lot of times, most people actually set up their bipods too tight. This one's actually set up real nice. I can set it up, turn it a little bit, let it go, and it'll stay there. You don't want it to where it flops like that left and right and it won't stay up. But what you do want is to where I can adjust it slightly without moving. You don't want it to go, and now it's too much. All right, so you actually loosen it up to where you can turn it a little bit and let it go. What you don't want to do is apply pressure to level your reticle and have to hold that pressure while you're pulling the trigger, right? Because that bullet's going to go somewhere else because it's going to be real hard to be consistent. And consistency is everything. That's what a ransom rest does for us, all right? A ransom rest is a device that we lock a weapon system into and it applies the same pressure to the weapon system every time to allow the weapon system to actually perform to its capability.
I know lots of school thought where I came from, and I know Chris has been taught this too, is to torque that thing down as much as possible. So you're basically saying, let the gun tell you what you're doing instead of, let the gun tell you what your body's doing instead of you just fighting the gun, and now you're adding tension.
Yeah, the whole thing with long range precision, we have to allow the weapon system to do what it can do. All right, we don't want to apply any pressures or push any errors that we have into the weapon system. So if I'm having to apply pressure and hold it there, all right, that's going to create inconsistency from shot to shot. But if I can actually set it up properly and then apply the same pressures on the gun every time, I'm just allowing the weapon to do what it can do for whatever accuracy it's capable of.
Well, I think that's two of the big things that have helped me is not torquing the bipods and cheek well, because I've had some schools of thought say you need to put a lot of cheek pressure into that gun, get it into the pocket, tighten it up as much as possible so you're not letting that gun move. But I think it's actually a little bit easier to let the gun move, so you can see what it's actually doing.
Yeah, absolutely. What we end up doing in teaching long range precision, we'll set up, put our fingertips here on the front of the grip, and then I'll coil up. Once I get on target, I'm looking through and I can see the target, get a natural point of aim. I pull this into my shoulder, so it's the exact same amount of pull every time, starting in this position. Since my upper body's partially coiled up, then we load the bipod till it starts to move like that.
Loading it forward.
Yeah, I load forward. Now I've actually tested, like you was talking earlier on cheek well, right? I've actually tested shooting groups, pushing down hard, barely resting on it, and then the pressure about like here where I'm about to go to sleep. All right, so in all the testing that we did for groups, we found that the same weight that you would actually just lay on it like you were resting is the pressure that actually performed the best. Now loading the bipods, we did the same thing. You can shoot with a reverse load, you could shoot with a neutral load, or a forward load on the bipod. The problem is we can't be consistent with the reverse load.
Yeah, how
we
much
can't
pressure
tell you,
is that
a neutral load or is that a neutral load? Is that a neutral load? We don't know. All right, but the same amount of pressure every time, just to where they start to roll out and hold that same amount of pressure each time, that's consistent. Now you can shoot good groups with a neutral load, all right, but the propensity for flyers is much greater. All right, so we know that with the same pressures applied every time, we're going to get the consistency that we're looking for. All right, so what we end up doing, to go over it again real quick, once we find the target, we coil up, pull into our shoulder, and then we load with our bipods into the target. And we're same pressure now, again, like I said earlier, if you're actually shooting something close, the knowledge is everything. You have to know where that bullet hit. You know, you shouldn't have to rely on somebody else telling you where your bullet hit if it's visible. All right, so if it's visible, I want to actually pull in tight like this. I'm still not wrapping my thumb. I'm pulling in tight like this, not applying a lot of pressure sideways, taking the shot, run the bolt, going back down, back on target quickly. But I've obtained the knowledge of where that bullet impacted. I know where I broke the shot, therefore I can make a more knowledgeable second shot correction if needed.
Is there more than one way to load the bipod?
Not really. Well, what I end up doing is actually, as I cool up, I'm doing my preload right here into my shoulder, and now I'm just laying my shoulder into it. What you don't want to do is drive the gun. You don't want to be up on top of the gun here like this and pushing down on it like this. What you really want is to be up underneath the gun, back here with your shoulder, let it ride up in the proper position. Again, this is what we're talking about with different weapon systems. Some are capable of that adjustment and some are not, you know, and we're going to go through those.
Are you driving with your feet or your toes at all?
No, I try not to drive with anything but my back. My back and my shoulders actually push the gun, but as you can see, I'm not trying to push this thing 5 inches. Yeah, all I'm doing is getting the same amount of pressure each time, so I go to that point right there. Now, if you are on concrete, up on top of a building, or you know, with some of the tactical guys, or you're out in the field and you're hunting, you're going to have a different feel, all right, with your bipods. It may be sliding more or not as much. It may be heavy dirt where you can kind of dig in and then push. You need to see where your bullet's going to hit with all different types of loads, because you know you're going to load heavy on some, you're going to load light because you can't load. You may have it on top of a building, set on the back of a vehicle, something like that, to where you can't load into it. Now, if we can, we'd even load into this in an instance like that. But you still need to notice, or you still need to take note and see where your bullets are hitting under all conditions, you know, at zero, at 100 meters.
One question I have is traditional military shooting over a ruck.
A lot of guys don't like bipods. A lot of guys just shoot on rucks.
Yeah, you know, shooting off ruck, there's no problem with that. It's a good, accurate way of shooting. Physics will tell you that this is actually a more accurate way of shooting. Now, and the reason I say that, if you look out towards the end of your weapon system, you have 2 points of contact, here and way out here in front. All right, that creates stability. As I move a ruck up under this point, it creates a fulcrum. So the gun can pivot. Now you have more surface area contact, but in reality, you have this much surface area contact because all of it's being supported. To where you bring the ruck in underneath you and you're shooting off of it, it's not quite as stable. And I've seen a lot of guys shoot off rucks. You know, we even shoot off of them in different positional stuff. They're not as accurate as this is. When I do testing for the military and I'm testing weapon systems or ammo, that's what we're doing. I mean, it was stated to me, you will shoot off a bipod, you know, and you will shoot off the ground. You're not going to shoot off a bench. You know, this was the way the weapon's going to be employed. This is the way the weapon will be tested. Obviously, if it was more accurate to test it the other way, when we're doing accuracy testing, they would want me to do it that way. All right, Steve, hop on the gun. We're going to go through a couple of things talking about eye relief. I'm going to kind of straighten your body out a little bit. What I want you to do is go ahead and move your body over in this position. Move to the right. All right, that looks good. All right, now what you want to do is go ahead and move this leg out. All right, now you have a nice straight spine. You ought to be comfortable.
What are you using as a reference, Todd?
Basically, what
I'm
trying to do
directly behind the gun.
I want to run the gun. The weapon system needs to run in a line just inside his right knee. From center of his right cheek to inside his right knee is acceptable. Some guys will run just nearly on the knee because they're not used to it. I wasn't used to this way of shooting either. I had to retrain myself because what I noticed was I could hit that sheetrock at 2 grand some shots I was completely off of it. So what I had to do is start from my feet, same way I used to teach myself on pistol. Start at the very basics. How am I standing? What's my stance? What's my draw? You know, everything, you know. So what we did with the rifle was the same technique, same thought process. Start from the feet. How do we approach the weapon system? How much load do we have on it? Just trying to be a ransom rest for the weapon system to perform off of, and that's what we're after.
Would you say also, you know, coming from a community that, I mean, I shoot what I believe is directly behind the gun just from what we do, but I've also seen a lot of long-range shooters where they're almost on an angle as they're shooting, and you see that in a lot of photographs or a lot of articles. So my question to you is, 1, does that screw, or can it have the potential to screw with accuracy? 2, not only that, but recoil management. I know for what we do for follow-up fast shots in our arena, we try to stay directly behind the gun so our skeleton can absorb most of it.
Absolutely.
So I guess my final question is, if I was shooting a big bore caliber and I have this offset behind the gun, does that negatively affect me?
Absolutely, you're exactly correct. What I'm going to do is move you in a bad position now to show. All right, so kick off over to the left side there. All right, keep going. Keep going.
Normally people raise a leg up almost.
Yeah, go ahead and raise your leg up.
Yeah.
So a lot of guys, you'll see when they'll kick that leg out and they're going to curl their arm up underneath the weapon system. I'm going to show you the effects of it. Now, a lot of times, why did we do this? All right, we did it to get our diaphragm up off the ground so our breathing didn't adversely affect our sight picture and what we're seeing and where the bullets are going. All right, so the problem with that is most of the guys I train don't have the opportunity to say, all right, hey, breathe in, breathe out. It's not target shooting, you know, so, and in that environment, they have to shoot on a minute's notice at any time, all right? So, it's, you know, it's just like hunting. If you're laying there and all of a sudden that prairie dog jumps out of his hole, you have that split shot, you know, to take. It's not target shooting, all right? So, and there's nothing wrong with target shooting. There's nothing wrong if you have the time in taking a shot doing that. But I train my guys to shoot the same way that we're breathing right now. So we're taking breaths constantly, just like we're talking, in and out. We're breathing, we're talking, we're aiming. You're constantly aiming the whole time. All right, the problem with this type of setup, especially when you start getting into 338s and weapon systems that actually have some recoil, you're gonna see that this weapon system can actually break his shoulder back. You know, the skeletal will actually bend back like that. Scope kisses him in the forehead. I mean, I've been cut 3 times back in my younger year, and even with a 50 cal not too long ago because of another situation, the way that we were shooting it. But if you actually line up properly, you can actually have full control of the recoil. But what I'm going to show you now is, if you'll actually watch, all right, go ahead and mount the gun in your shoulder. All right. Now, you're going to see a little recoil, all right? Now, what you're going to see is the way it moves his spine. The adverse effects of it, all right? I'm not saying he won't hit his target shooting in this direction, but most of the time the guys can't get back on target and see where their bullet hit. And knowledge of where your bullet hit is key. So I'm going to feed him a little recoil, and you're going to see how it kind of moves him around, all right? As you do that, and it turns his body like that, when he comes back down, he's going to have to be wiggling around trying to find his target again. He's lost that knowledge. So by moving him back around, go ahead and scoot back around. All right?
And moving Steve's not an easy task.
No, it's not. That's a lot of man.
What I'm feeling is a lot of the stock on the caliber.
Yeah, actually the stock needs to be right in the pocket. I mean, right there. Can you feel that little pocket? Yep. That's actually where you want the weapon system to set. All right, so when you actually have a nice adjustable stock like this, you can actually move the cheek piece up and down, or even move this butt piece up and down as well. It's very adjustable. And so that's one of the nice things about different types of weapon systems, and some of the advantages that we get out of them is adjustability. So we're going to go through some things real quick. All right. Again, we're going to move fingers to where they're right in front. All right. Placed just like that on the front of the weapon system. Thumbs on the right side. He's using only the rear bag for aiming. All right. He's in a good line with his body. Now this is about minimal. All right. Actually, I would actually want him to scoot it out in this position. And with a lot of my students, I actually do this to them. I actually take the weapon system away from them. All right. Go ahead and be comfortable, lay down. All right. Just like you're going to take a nap. All right. Then I actually mount the weapon system just in a perfect position like this. All right. Go ahead and grab the gun. All right. Rear bag it up. And that is actually a perfect body position right now. His spine is straight. He shouldn't have any muscle tension trying to hold him in that position. All right, now that he's got his fingers in the right position, his elbow's pushed out. All right, you want your elbow full pushed out. That way you don't get that break back of your shoulder under recoil, and that scope doesn't kiss you in the forehead. So you can shoot 338s without even a break, something that's going to recoil pretty heavily. If you shoot it properly, it's going to push you away. It's going to fall right back down on target. All right.
How much pressure are you looking for in the weapon hand?
Actually, just enough, the same amount every time, pulling in my shoulder. It's a fair amount, but you're not gripping it, and that's one reason I decided to go with that grip. I couldn't actually grip it and rip it into my shoulder. Now, some weapon systems, you do have to do that too. And, you know, a lot of the AR style platforms that we shoot, you have to grip them pretty hard and pull them into your shoulder hard and kind of manhandle them. Some of the other AR platforms like the LaRue OBR, you don't have to shoot that way, but because of the machining of the OBR, you have a semiconductor machinist building them with such good tolerances that still run when they're dirty, because he knows what he's doing and he's able to actually put them together to where you can shoot them just like a bolt gun.
And on those other guns that have loose tolerances, you got to actually torque them, pull them in to tighten up the tolerances yourself.
Absolutely.
That's a great thing about
Absolutely.
But you would have to do that every single time.
Every time. It's that whole consistency and accuracy.
That's
thing.
important for people to realize, because they're like, well, what's going on with my gun? What's going on with my gun? I got this $3,000 setup that I franken gun together. And next thing you know, it's because of that simple fact is the tolerances are too loose.
And they may have a $1,000 barrel in it and not understand why their groups are shooting horribly.
And ARs are big right now. I mean, that's a very important thing to think about is those tolerances. You got to be consistent in that grip every single time you grab that gun.
One of the neat deal with ORs, it's kind of the 1911. You can do a lot of different things to it. Kind of like the 1022, you can do a lot of different things. So you can kind of build your own gun in your garage, you know. So it's a neat weapon system. But when you're actually putting parts together and building your own weapon system, you got to be aware of the tolerances, you know, and we don't have the ability, most of us, to go in there and buy a bolt and mic it and pick the one out that's going to fit right for your weapon system. So when you look at buying one, understand that that's some of the advantages that you're getting when you buy from a quality weapon producer or manufacturer. You're going to actually get a weapon system that potentially, not all of them, you know, we'll be honest and say that some are good and some are not, but you're going to find that the good ones, that's the reason why they're good. The tolerances are where you can actually shoot them. And if you don't have one like that, you can still get the most out of it in accuracy by doing just like you said. applying the same torque to that handle every time, holding it, pulling in hard, to make those tolerances react the same every time as you're shooting the weapon system. All right, so now that he's actually gripped up, he's pulling into his weapon system, all right, he's relaxed, he has no tension, all right, because we're type A's, we've got this closed right now. I'm gonna pop it open, and he's gonna look and tell me if he has any scope shadow.
A little bit.
All right, move your head until you don't have scope shadow. All right, so he had to come forward. So initially, there's a couple of things we could do. We could actually collapse the buttstock down, or we can actually move the scope back towards him. All right, you ready? You relaxed? All right. Any?
Nope.
All right, so he's good. So we'll go ahead and we'll close these down. Now, what you're gonna wanna see is you're gonna see them get tied about 60 degrees out, anywhere from 45 to 60. I like 60, all right? And then you can mash them in, all right? But you need to be able to put a knuckle behind them to get them off. You know, if you can reach up there and just flip that thing off, it's not tight enough. And we'll actually tighten this up a little bit more than it is right now before we start shooting.
For a lot of the military that uses like a Badger Ordnance style rings, you know, your classic military rings that you see out there, what should those be torqued to once you get things set to where they need to be?
Yeah, they need to be torqued down to 65 inch-pounds. Most people will tighten these up, you know, to about 20 is what most of the time everybody does. I'm probably a little bit more. You know, I don't want stuff to get loose. I use real high quality gear, and I can torque these down to 25, no problem. I don't get any
the actual scope ring.
The little screw.
Yeah.
The scope screws or the mounts. And then on the normal style that has a nut, you'd want to torque that down to 65.
Todd, do you feel it's an urban myth, or is it important, the procedure of mounting one of these Picatinny interface bases, to set them in the rail and load them forward before operating the
Absolutely, and that's when I actually put that on, that was something that we actually did. Once you put it on, this hand, I just didn't talk through it, but you're exactly right. You want to push it towards the front of the weapon system, because that's where it's wanting to go under recoil. You don't want to actually zero it back here and then take several shots and finally, eventually it slides forward on you, all right? But yeah, as you start putting it on, I'm already pushing forward and locking it into place. That's a good question though. Now is that set up proper again for you to get it back in the same holes?
Good.
All right, you're good. I take these little scope or these rail clips, and I'll actually place them right here in front of his scope. So if I take it off, now I know exactly where I need to go back to, because not every tooth is actually going to give you the same amount of accuracy. All right, this is precision work. You know, we're not just trying to get it in a 1-inch pasty somewhere so we can move on to other things.
Now, when do you think you would ever want to take your scope off? Because I know a lot of guys are like, I'm never touching it. Once it's there, it's there.
You know, tactically, there's a lot of reasons you'd want to take the scope off when you're jumping in. You know, in other types of missions that they do, they can run in with different type of optics on, and then move into, you know, a different type of scope, a long-range shooting scope. But you know, even I back in up in the mountains, and I'll carry my weapon system, and if it's going to be, you know, a certain type of hike, or if I'm actually packing it in, because I take my scopes and fly with them all the time. I'll ship my weapons, you know, underneath the belly of the airplane, but I'm gonna take this, you know, nice piece of glass, and it's riding with me, you know, up in cabin class. So, but
most of the time it rides in first, and still trying to work that out.
If I can leave my bag in first, it gets to ride in first, but I go back and sit with.
What do you think about lapping rings on?
You know, that's a good question. You know, you really need to if you don't buy quality rings. And to be honest, I've never had to touch any of the LaRues, and I run LaRues on everything because they are super high quality. But if you do have a set of rings that you want to use, running a lapping set through it,
it's not gonna hurt.
It's actually probably needed, you know, because I've seen a lot of them where there's only contact. You take them off, you look at them, and only the first maybe quarter inch was the only thing that was ever touching. All right, so you'll see those scopes slip and slide back because you don't have that surface contact. So as you lap it, you're actually getting more to actually hold, getting a better bite. All right, so now I want you to go through the process, all right? So you've actually loaded up, pulled into your shoulder. You're gonna kind of cool up as you're looking at the target. And guys, all this needs to be while you're actually zeroed on the target. You already have your crosshairs on the target, or if you're using a system like this that has H58 Horus reticle in it, you're actually going to place, you know, maybe a 4 mil hold on the target. You're going to place that 4 mil hold on the target when you're coiled up, and then as you load into the bipod, that natural point of aim is very important. What you don't want to do is push and then try to waller over here and get your 4 mils back on your target or your wind hold. If you're holding 2 mils to the right, you want to line up with 2 mils right, load into it, because what you don't want to do is push in and then torque it over. You're applying pressures to the weapon system that you don't want it to be there to maintain the accuracy that you want. All right, so what I want you to do is go ahead and load the bipod. All right, so you're going to do it slowly. All right, right there. You see how it just barely moved?
Yeah, you could hear it creak.
As it starts to move, don't stop, just hold what you got. Because if you stop and relax, you've just lost everything that you gained. All right, so, and it's going to be a little bit different today unless you've been used to doing this, because what you're going to get is every now and then the guy won't load his bipod. So he shoots, and then all of a sudden he has a high flyer. And while he had a high flyer, you can actually watch, he didn't load his bipod, and the gun's going to rock back, you know, exponentially more than it did in the previous shots. It's going to change his launch angle of his barrel, and he's going to hit high. All right, so that's something that we'll watch today once we get going. All right, so the big deal is it's just consistency. Long range is really easy. You know, precision accuracy is pretty easy. All you have to do is apply the fundamentals. Everything works out for itself.
My question is, Todd, what about length of pull in a gun?
All right, you know, I get that a lot. I get guys that, you know, talk about length of pull, kind of like we did with our shotgun back when we was, you know, growing up shooting quail and dove, you know, setting up different guns for us. The reality is, because the way that you're shooting that weapon system right now, length of pull doesn't have anything to do with it, all right? You know, if you're shooting a shotgun and I'm mounted up here like this and I'm swinging with clay pigeons, or I'm shooting quail or dove, absolutely, you need a gun that's fitted for you. But what we're doing, most of my guns are an inch under what you would consider a normal length of pull. All right, so if you're running a 13.5, I'm probably a 12.5, you know, off of a normal 13.5 length of pull, because you can shoot with a shorter gun, all right, but it's real hard to shoot with a longer gun. And what we initially do, if we don't set the scope up right, you see guys start canning off to the right or canning off the left side of their gun, and now they're offline. Now they can't actually see their impact. So, you know, once we get into it, you're going to see a lot of little changes from, you know, what we've thought in the past was the correct way to do it. And we're not trying to change the world. We're just trying to question everything. You know, I tell my instructors that I teach, if you have anything that you're fixing to go over that you haven't tested but you aren't for sure, go out and test it. You know, it's not what we teach, and I'm sure y'all feel the same way.
Absolutely.
It's not what we teach is what's right, because we don't matter. What matters is where the bullet hit. The bullet's the truth. So if you actually teach where the bullet hits, you can't be wrong, all right? Nobody can argue with you. They're arguing with where the bullet hit, all right? So my deal is, it's not me, it's not my opinion. You know, it's not, I don't build my formulas off some math scale that I've got in my head. I built my formulas off where the bullet hit. So you ain't gonna argue with where the bullet hit. If you argue with that, you're gonna lose. It's not me. I'm just writing everything based off the knowledge of where the bullet hit. Once you get on target, what I want you to do is go ahead and line up on one of the dots, all right? The first thing we're going to do is adjust your ocular focus until you have a real crisp reticle, all right? You do that back here at the rear of the scope, all right? You can see it getting blurry and getting hopefully sharp, but I want you to take your hand up here and actually move this until your reticle is super crisp. Now, different scopes, you're going to see different things.
Todd, what magnification should you adjust the ocular?
Actually, I do it on full. All right, because you're going to see the parallax. The more power you have, the more parallax you're actually
So there's a
going to see.
lot of different procedures I've seen out there. Is that specific just for this scope?
No,
We can
no,
go
that's-
ahead and look at it and make the adjustment?
Yeah.
Because I've also seen it done in the past with either your technique with the scope cover closed or actually panning up at the sky with something featureless and looking away from it and then looking, does it immediately appear?
Yeah, actually, that's a real good question. What we were doing with flipping the scope on and off was, or the scope cap cover on and off, was actually getting the proper eye relief. All right, so since we're type A personalities, he's not pinching forward. So if I have it closed and he opens it, I see him move forward. But to actually get it, a lot of times, since we're type A's, we'll load into it and go, yeah, I'm good. well, you're not really good. You need to actually be relaxed on the weapon system. So this allows us to actually find the student's relaxed position and open it up. Now, what we're doing with ocular focus, you're right. If you look at the sky or look at a white object, something like that, and get real fine, crisp edges, you're correct. I found that when I was younger, I had 20/10 vision. So even now I can see really well far away, but I can't see very good close up. It's actually a little bit of an advantage for what I do in long range training, is because I can look at your scope real quick and tell if your parallax is screwed up, because your reticle is going to be blurry for me. My eyes don't adjust. And that's why they're making the younger eyes actually look up at the sky, look at something white, look out and look back in the scope, because your eyes will adjust to something pretty fast. And that's what we're actually seeing with the students that we're working with. I'll get down behind the weapon system and you'll see that their reticle is blurry. And then I'll adjust it, adjust the parallax, adjust the ocular focus, adjust the parallax. All right, everything's set. I move my head around, nothing's moving. I'm good to go. And I asked him to hop back on the gun. He goes, yeah, man, it looks great. Well, it looked great to him a while ago, but because his eyes adjusted really fast. And that's why we actually have to pull our eye out. If you have really good young eyes, pull your eye out of the scope, look somewhere else, pull back in, and you have to take a quick assessment of whether your reticle's blurry or not, because your eye, if you have good eyes, will adjust pretty fast. So go ahead and adjust it till it's super crisp. Once your reticle is super crisp, then we're going to actually take and turn your parallax knob until your target is really crisp. All right, this may take a couple adjustments, but we'll walk you through it. So now I want you to aim at the top of a reference mark, anywhere on the target. All right, as you line up on the reference mark, slowly I want you to move your head up and down without manipulating the weapon system at all. All right, so as you're moving your head up and down, you're probably still seeing a little bit of movement, separation. So what we're doing is putting the crosshairs right on top of a dot or a line, and as he's moving his head, you'll see separation from the crosshairs to where he was aiming. All right, and that becomes a problem, because if we don't remove all this parallax, if I move my head from here up to here for the next shot, where I think I'm aiming at is not where the weapon was actually sighted for and where I'm really aiming at. All right, so that's where you see that big jump.
So you go up and down, right?
Yeah, you'll go up and down, because the cheek weld is going to keep you from really going left and right really well.
Because I've been taught left and right, just get behind, shake.
Yeah,
shake.
you can get behind. As long as you're not moving the gun, it really doesn't matter. All right, so a lot of times you can set a rear back up under it and just move your head any direction. It really doesn't matter.
So your head obviously moves more naturally up and down.
Yeah, usually I just work my head up and down slightly like this. And I didn't even realize what I was doing. I was working with some Marines out in Utah doing high angle training, and I found myself, they were laughing at me. And I was like, all right, guys, give it up. What's up? And they said, every time you look through glass, you check your parallax. And I said, yeah, you're supposed to. He said, no, even on the spotting scope. And it became such a habit to me every time I look through a piece of glass, even when it's my spotting scope, I look through it, I catch my head wiggling. I didn't know it until they told me. Now it's something I'm self-conscious about. So, I mean, but you catch yourself wiggling your head, just slight little movements to check for parallax. All right, so once he does this, if there was a slight amount of movement, he adjusts the rear ocular focus slightly, again, till it's real crisp. I mean, it still may stay crisp, but you move it in one direction, all right? Reset your parallax or target focus, make the target as crisp as possible, and then move your head again. If it's a little better, you continue in that direction. If it's a little worse, you back off in the other direction. And you do this, and guys, most of the time, this is one of the #1 things I see with everybody that comes through the class. We don't spend enough time adjusting our parallax properly to where we don't see the effects downrange. And one thing everybody always wonders, if you set up a gun for one person as opposed to 2 people, can 2 people shoot the same gun? Well, sometimes they can, depends, all right? Sometimes they can't. If the parallax is actually fixed, you're probably going to be able to shoot really close, all right, if it was adjusted properly, all right? Because all that we're doing, because of ergonomics between our eye and our cheek weld here, we're moving automatically up because of your ergonomics. So if he zeroes a gun, I should be able to get on that same gun and hit the same spot if the parallax was perfect. Because if the crosshairs are lined up with where the bullet's going, it doesn't matter what we're looking through. If I put a scope camera on it and I'm looking at a monitor and I line it up and shoot, it's the same thing, all right? But because we don't fix a parallax, I mean, this is something I really didn't understand was that big of a problem in the shooting community, was most scopes aren't fixed to where there is no parallax in them. You can adjust them, some are harder than others, but you can adjust that scope parallax out to where most of the time it's pretty nice, you know, and there's not that much movement. Obviously, some scopes you probably can't get it completely out, therefore you to you will have a different impact shift determined by where your eye is placed inside the scope. All right, so let's hop on our other guns and let's talk through the different variables that we have with different weapon systems. All right, guys, we've already covered the safety brief. Let's go ahead and lock and load, and we're hot. All right, go ahead and get behind the weapon system. All right, kick your left leg out a little bit more. That's straightened up your spine a little bit. That's real good body position. Now with the LaRue OBR, you don't have to actually grip it real hard here. It's just a light grip. You don't have to use the same grip that we use on the Remington MSR, but it's just a real light grip and a good heavy load on the bipod. The gun really likes that.
Okay,
all right,
I'm loaded.
Yep. You've already set the parallax?
Parallax is set. And I'm on a 220, 30 yard parallax at 100 yards. So where most people, I think, we're always used to like, hey, put it on 100, I'm at 100, I'm at 200, put it at 200, 300, put it at 300. What do you think about that?
Well, not all the dials are actually calibrated perfectly. So, and I've shot different types of scopes to where you're shooting at, you know, 700 meters with your dial set on 300. So I really don't ever pay attention to that. Most times Smith Bender is nearly dead on. It may be what you're seeing with your eyeglasses, with the perception of what is actually clear or not. Most of the time the Smith Bender scope is closer than the rest of them, but it's one of those deals, I don't even care what it says. I just turn the dial to my targets and focus and I'm good to go.
That's something else we should probably talk about real quick is eyewear. I mean, we are precision shooting here. I mean, most people think, hey, when you're shooting a weapon, period, you should always have eyes and ears on. However, there can be some difference with when you put another lens behind these lenses. Is that correct?
Absolutely. It depends on your eyewear. And good quality eyewear may not give you a problem. Obviously, poor quality eyewear is gonna create a lot of problems for you. And then what you got to look at, you know, if you're square behind the gun and you're looking through your scope and you actually cant your head slightly, you know, to get on your cheek weld, you're inducing an error, you know, if your eyewear is not good. So initially what I tell you to do is set up your parallax without your eyeglasses on and sit there and make sure it's perfect. And then if you want to shoot with eyewear for safety reasons, then you can go ahead and look at it. But then adjust for your glasses the same way that you check for parallax. You put your glasses down, move your head back and forth, figure out which angle you're going to be shooting with your eye looking through those glasses and see if there's a movement with your reticle on the target.
Okay.
All right. You're running the 110, all right? 110 is a current military system, all right, that is in service today. This weapon system, you don't need to shoot with a light grip. You need to try and manhandle this gun, all right? You want to make sure that your bipod, that's good, it's not too tight. You make it just a little bit looser, all right? That's pretty good there. All right, now you actually want to go ahead and grip this gun. I would actually put my thumb around on this gun.
Okay.
All right, you really need to, what I try and tell the guys to do every time is you want to take out the play in this gun as much as possible. So once you line up your crosshairs, you can have your crosshair just slightly canted on the target and bring it in the same every time. You really want to grip it hard and pull it into your shoulder too. And then once you get lined up, then you actually load into it and break the shot.
And mainly what I'm looking at is being consistent with that consistent grip every single time.
Yes.
And torque on the gun is what you're saying.
Absolutely. That consistency is everything in shooting. So obviously in precision shooting, it's even that much more. So if you actually do your job properly every time, we can probably keep the gun somewhere around a minute.
Okay.
All right. All right, Mike, that is near perfect body position, all right? Now, you got your parallax set? Everything look good?
I'm having a little trouble with the comb height. When I get behind and lay down like I'm falling asleep, like you were saying before, I'm looking towards the bottom portion of this.
All right, let's fix that. All right, what I'm gonna have you do, I'm gonna move this up. All right, now go ahead and place your cheek.
Okay, it's looking a lot better.
Need to come up?
No, that's just about perfect.
All right, move your head away. All right, Let's go ahead and check that. Let's go ahead and open your bolt and see if it'll clear. It'll do fine since it's a short action. So if it's a long action, it may give us a little bit of a problem, but that'll be fine. We'd have to actually drop it, take the bolt out. That's another reason I really like folders. You don't have to keep taking your cheek weld off every time you clean your gun and then trying to reposition it. You just fold it out of the way like we will on this other weapon system over here. Is that better?
It's a lot better.
All right, keep working with that. Steve, scoot to the right just a little bit. There you go. Block out your right elbow. There, better. All right. Your line's coming down right through there of your stock. So right here is where you're at. Everything looks good. Yeah, good. And when in shooting bolt guns, Mike and Steve both will shoot with your fingertips right on the front. All right, shooting gas guns, you're gonna go ahead and grip the gun.
Okay.
All right, this is precision, all right? We're sighting in, we're not doing snaps and movers, all right, where we need to go ahead and grip the gun, even a bolt gun. So what we're gonna actually do is run the bolt guns gripped up like this, loaded with a medium load into our shoulder, good forward load on the bipod, break the shot. Everybody's good? All right. All right, everybody go ahead and start off. Line's hot. All right, Travis, last target on the right, center diamond. We like to really refine our aiming reference points. We just want to shoot at the center of a big black square. All right, so.
Center diamond.
Yeah, center diamond, right on the apex. Heavy load on the bipod, light grip. All right, go ahead and send me another one. Bottom of the apex. 6 o'clock hold on the center diamond. Perfect. All right, send another one. All right, I'd probably come up for the average of my group right now. I'd come up 1 click. So that's sub half-inch group. That's good. All right, Chris. You up?
Yep.
All right, target number 3. Aim top left corner.
All right.
Can you see that?
Yep.
Top left corner of the paper. Give me a shot. All right, give me another one. All right, one more. All right, go ahead and come down 3 clicks and come left 3. Mike, you up?
I am.
All right, target number 2.
Okay.
Give me 12 o'clock on the center diamond. All right, send one more. All right, that was perfect. Send me one more. It's an inch left. Your elevation is good now. Send me one more. We may have to go ahead and make the adjustment and come left a minute. Yeah, all right, give me, that's a meal scope, is that it? MRAD correction? All right, give me 3 clicks right. All right, Steve, center target, first target, 12 o'clock. Other diamond, go ahead and give me a shot. Need you to come up 4 clicks. Come left 1.6. One more. All right. Same shot, 12 o'clock. Perfect. Do it again. right, give me another shot. All right, you stacked the last two. Go ahead and give me 3 clicks left. Same shot, 12 o'clock. Give me 1 click right. All right, everybody's real close. What I want you to do is go ahead and give me a 5-round group. Find something very refined on that piece of paper to aim at. All right, load bipods heavy, consistency every time. Do the same thing. Try and get a 5-round group and we'll adjust off that if we need to fine tune. All right, bottom left target, 12 o'clock on the diamond. Bottom left diamond, 12 o'clock, 5-round group. All right, make sure you load your bipods. Real consistent every shot. Really refine what you're doing.
All right, I just switched to my 300 Win Mag bolt gun, and I was trying to zero it, and I'm shooting high. It looks like 2 feet above the target, and I'm bottomed out right now. I can't do it, and I think it's because of my mounting system.
All right, I'll tell you what, let's do. Let's find a reference target to shoot off of in the dirt. All right, look below target number 1. There's a yellow bush. 12 o'clock of that. Give me a shot. Yeah, you're 4 mils high right now. All right, come down 4 mils.
Okay, it's bottomed out.
All right, how much was you able to come down?
I was able to come down 1 mil.
All right, 1 mil. So you're gonna be 3 mils high. All right, you got 20 minutes in your rail, and that mount has 20 minutes in it too. So it's a little bit too much for that system.
So about 40 mils. Okay.
So there's either one of 2 ways that we can work with this. One, you can take a 20-minute scope mount, turn it backwards on a 20-minute rail, and it'll make everything flat.
So I could flip the rear one around.
Yep.
And that zeroes it out.
Yep, and zero it out.
Okay.
All right, just a kind of quick common sense approach. Or I can show you something else that we can actually continue to use and make it happen right now. Let me show you something.
Okay.
What I want you to do is go ahead and give me a shot. Aim 6 o'clock on the bottom diamond. We got to figure out where you're at. Center diamond, first target, 6 o'clock.
Okay, hitting the head? No?
Yeah, you're right in the neckline. You're actually about 3 mils high. I'm gonna make you 5 mils high. You've got a regular mil dot reticle.
I do.
All right. Regular mil dot reticle, I'm gonna actually place your 0 at the top duplex. And then it's what we call a poor man's horse. We do it with a lot of other Gen 2 mil dots or any type of mil dot scope. We'll actually 0 our crosshairs at 100 meters and then either dial up 17.2 minutes of angle or as close as we can get with that scope, or we'll dial up 5 mils, which is the same equivalent.
Okay.
All right, so go ahead and give me 2 mils up from right now.
Okay.
All right, is that 2?
That was 2. Well, that's 2.
All right.
All right.
What I want you to do now is hold top left diamond, hold center with your duplex, top duplex. So we're 5 mils above our crosshair now.
Top left diamond. So.
Top left diamond, center. All right, need you to come left. Same hold, duplex, but I need 0.7 left on your dial.
Same hold.
Yeah, top left diamond, top duplex. All right, go ahead, give me one more shot. All right, come back right, 2 clicks. All right, left and right's good. All right, from there, we're actually gonna line up from now, and you're running what we call a poor man's horse. So you start out at the top, duplex is at 100 meters, 1 mil down equals 1 mil down, 5 mils is your crosshair, 10 mils is the bottom duplex.
I'll be damned. Okay.
It's the same as just doing pure holes, but now we're using the top half of the reticle.
So I can actually use this system
Yep, absolutely. So it's kind of like a problem solving on the range.
on the range.
We don't have the right equipment, but now we could go ahead and flip the scope mount around and actually fix a problem that way, or we can continue and fix a problem in the field. It's kind of like a broach scope drill.
I kind of like that though, because it's simple to count. you
Yeah,
know?
it is. You don't have to remember any holes. It's not like the 500 meter hold over, hold under drills. I was getting some kids ready to go to SODIC out of one of the groups that I was training, and we were actually teaching some of the stuff that they teach in SODIC, and one being the 500 meter hold over, hold unders. And when I looked at it, the reason that you would actually do that is for speed. You know, the reason you'd come up with that kind of drill. But the reality is you're gonna have 3.8 dialed on your scope. You know, that's where you're actually zeroed right now. And then if you have a target at 400, that holds 2.4, so you're gonna have to be above your reticle or above the crosshair, 1.4 mils, but you're doing math. Math isn't fast.
No, I'm not
Alright?
good at that.
But you're gonna know that when he says, hey, target's 400, you're gonna hold 2.4,
Yeah.
2.4 down from the top.
So it's all just
There
keep
is no
counting.
math. It's just you remember your holes and it's all right there.
That's really easy actually, and even with not the right gear.
And now
But I actually like that better almost.
Now the only thing that you got to kind of watch is it gives you, when you're running night vision or something like that, if you're running PVS 22 and now you dial down and you're in a second focal plane, of course this one's not, but if you're in a second focal plane and you dial down, you've got to come down to half power. And if at half power, it makes all the mil dots worth too. So really you're zeroed 2.5 mils above your crosshair right now, the equivalent of 5 mils. So it gets in the way, but there would be no reason to ever run it that way unless you, like this, we had the equipment problem that we fixed in the field. You just have to be aware at that time. But now it gives you the ability to actually utilize all of your scope instead of just the bottom 5 mils.
Okay.
All right, let's load up. What we're going to do now is sit down and look at each different type of reticle and learn how to maximize the use of each one of them. First off, we're going to go to a duplex reticle, probably the same reticle that you started out shooting with when you was young. All right, looks something just like this, straight line crosshair, heavy duplex up top and on the sides. All right, now traditionally what we used to do is just zero the crosshairs either at 100 meters, 100 yards, or we'd zero the gun to where it was actually impacting a couple inches high, which would actually give us some kind of a max point blank benefit and would allow us to shoot at targets, 2, maybe 300 meters with a little bit of holdover when we got up to 300 and 400. All right. If you look at the reticle though, we can actually take and turn this reticle into a ballistic reticle. All right. If you actually zero the weapon system here, you can actually now, once you know what this measurement is, all right, there are several different ways to find that measurement. If you have another type of reticle like a mil dot reticle where you can actually line this up now and actually mill the difference from the duplex to the crosshair or all the way from one duplex to the other, then we have a unit of measure. Or you could even take a tape measure out there and figure out exactly what that would actually mean in mils. But once you zero here, let's just say that this is equivalent to 1 mil here and this is equivalent to 1 mil here. All right, what is a 1 mil hold? All right, for the weapon systems that we've been utilizing, a 1 mil hold would be somewhere around 254 meters. All right, so that puts our crosshair at 254. All right, so now what is a 2 mil hold? 2 mil hold is going to be somewhere around 360. So our bottom duplex is now 360. All right, so now instead of just having a crosshair and being zeroed on the crosshair, maybe a couple inches high where we can reach out, but now we're having to fudge. Long range precision is nothing about fudging. We're not trying to guess. We're trying to do something very accurately. So even with a old school reticle, just old school duplex reticle, we can zero our crosshair here, be zeroed at 254 meters, and then be somewhere around 360 meters out depending on your muzzle velocity. So again, it helps to have the actual PDAs you can run through a ballistic program. And there's a lot of different ones you can actually utilize. Now the problem that you're going to run into is, let's say this is a 3 to 9 power scope. All right, once you have a 3 to 9 and you're running this at full power when you zero the weapon system, when you back that power off, everything's going to start changing. The one thing that doesn't change is your 254 meter zero. That stays constant. Your 100 meter zero up here isn't 100 meters anymore. So if you actually back it out to half power, and what you have to understand, half power isn't necessarily half power on what's marked on your scope. So if you take a 3 to 9 and actually turn it back to 4.5, you would assume that's half power. But you actually need to check it. What you need to do initially is mark top duplex here, bottom duplex here, and then take and turn your scope down until your crosshair is here and the bottom duplex is here. All right, this would actually tell you that now you're exactly half power on that scope. No matter what it says on the ring, this is half power now. So once you get to that, this now becomes your 100 meter zero. Your 254 actually stays the same at all times. But what does that do? Once we're at half power, this is equivalent to a meal, this is equivalent to a meal, now this is equivalent to 2. Make sense? All right, so now we're 1 meal down from our zero here at 254, but now we have 2 meals worth of use past that. So now our bottom duplex is really equivalent now to 3 meals. All right, so a 3 meal hold for your weapon system is going to be somewhere real close to 435 meters. All right, so now when we actually change, we'll move this over here to full power, all right, at 360. But when we are at half power, this here turns to 435. All right, so again, by manipulating the power ring on our magnification, we can actually very accurately turn a standard duplex reticle into something that's more useful, and you can actually reach out to range instead of going, I don't know, I held a foot over his back, you know, that kind of stuff. So now we can actually utilize this, and you can continue to back down your power ring. All right, so as you do that, you can work further down, and all these numbers will change. But again, you can go out and shoot it, but it's much faster once you know what each line represents in meals. It's pretty fast to run it through a ballistic computer. If you know your muzzle velocity and your ballistic coefficient, your density altitude, you can actually run this through a ballistic computer or ballistic solver and actually have real precise holes all the way out to distance. Yes?
Got a question for you, Todd. If you back it off a little bit more because you're trying to work on getting a little bit further with your scope, would your center crosshair, no matter what, always stay at 254? It's just that you pick up more mils on the bottom. Is that what's happening here?
Yeah, absolutely. And really, basically we're zeroing here, you know, at 100 meters, but really we're zeroing at 100 meters for 254 meters is what we're doing. That zero is going to stay constant. As you run through your power ring, it's not going to change. All right, so this is old school stuff. This is what we used to utilize, and it's still a really good tool today. All right, now we've stepped up into meal dot reticles. Again, we have the heavy duplex, and the heavy duplex at low light actually helps us sometimes see exactly what we're aiming at. The crosshairs, you know, if you're not utilizing illuminated reticles, a lot of times the crosshairs kind of get to where they get washed out and we can't see them. So the heavy duplexes really kind of help us pick up what we're aiming at the time when there's no light. All right, same thing with this. What I decided to do, instead of using a lot of max point blank like we did in the past, or running 500 meter hold over, hold under drills, what we ended up doing was actually zeroing here at 100 meters. All right, if you're working with a meal type turret, you can actually dial 5 meals up and put your 100 meter zero up here at the top duplex. All right, what this gives us, if you're working with a TMOA scope, it's 17.2 minutes of angle equals the 5 meals. So if you're running either one, you're going to have to dial. If you're dealing with minutes of angle, you may only have 17 minutes is all you can dial. Or if you're in a quarter minute, you can dial 17.25. All right, but that gives us the same thing to where we're zeroed up here at the top. Now what this does, instead of doing like a 500 meter hold over, hold under drill, all right, or having a 300 meter zero on your gun and you're actually, you know, up in the top portion with your crosshairs for 100 meter, not your crosshair, but your actual hold. This allows us not to have to do math because that's what it's all made for. So basically what we call this is a poor man's horse. The poor man's horse allows you now, if I'm looking at a target and I say it's 305 meters, I know my mill hole's 1.5, I'm gonna put it right here. It's 1.5 mils down from the top. I know if I'm gonna shoot 400 meters, it's 2.4. So I'm gonna hold here. This would be 305, this would be 400. All right, if I know my holes for 600 is 5 mils, this equals 600. All right, so right now, very quickly, if I already have my dope sheet in my scope cap cover on the side of my gun, or I've memorized my holes every 100 meters out, very quickly, if I say, hey, I got a target at 780 meters, my hole's 8.2, all I have to do is look down and go to 8.2 and hold. So it's a very refined way to do this. Now, the problem that you're gonna run into is when you start getting out here on wind calls. All right, because holding out in space, and that's one of the huge benefits of the horse reticle, is that we always have a refined aiming reference point with the horse reticle. When you're holding out here in space, for one, it's hard to actually know exactly how much you're holding out. The other problem is when you actually think you're holding here and your bullet impacts here, you break that shot, you fall back down under recoil. The next thing you're gonna see is, all right, I see the puff of smoke or I missed my target, now where do I make my adjustment? You don't have any good measurement to go off of. It's not very quick. So a lot of times we have the guys actually go ahead and dial their wind if the wind's blowing like it does out here. So usually, I never tell the guys to ever dial wind, all right? We always hold for wind because things change. In a tactical environment, you may have a mover and you're holding, you know, 2 mils for a 4 mile an hour mover or 2.2, and you also have wind. So you're holding for both of them, but if that target actually turns around and moves the other way, now you have to start taking it off, and if you've actually dialed it on, now you're reaching up there and jerking stuff off and it's slow, and if the target's moving left and right, you know, it's kind of ridiculous to be dialing. For right now, we're just doing pure holes. This is the only time I actually tell guys go ahead and dial for wind is when we're actually using a poor man's horse like this. It's still a mill-based system, all right? So we can still use it when we're doing mill relation formulas to figure out how far away the target is. You can actually take the size of the target. If the target's 12 inches, divide it by what you mill it. If you mill the target at 0.8 mils from here to about here, if the target mills that size, the target's 381 meters away, all right? So you can utilize that by going 12 divided by 0.8 mils, all right? Once you do that, times 25.4 will give you 381. Now, if you're working in yards, you'd times 27.778, all right? So you can still utilize this the same way it was meant to be utilized. This is just a more refined method of utilizing a standard duplex. All we did is start adding in dots all the way through, all right? Now, once we went from this, a lot of guys started going...
Quick question for you, Todd.
Yep, go ahead.
Before we take that down. How do you find the system works out with using a more traditional mill dot system like the old oval-shaped USMC mill dots?
You know, I really didn't like the oval. They were 0.25 tall. You know, this is actually pretty good because you can actually take and refine it a little bit. All right, we'll make them a little bit larger. In some of the better systems, mill dots, there's a lot of different types of mill dots. Some have half mil subtension marks like this, all right? And then once you get out here, all right, some reticles actually look like this where there's 0.2 subtensions, all right? This is on left, right, top, and bottom, all right? So again, it's a good way to actually mill a target out. Anytime it is subtended more, what you're gonna find is you can actually more accurately mill that target. Instead of looking in here and going, I don't know, the target's from here to here, all right? Well, that's a little over a half. It may be 0.6, maybe 0.65. I don't think it's 0.7 yet, but we're guessing. We're trying to extrapolate, and that's the problem right now. So when we actually changed the reticles and we gave them half mil marks, all right, it made it much easier to actually guess and actually kind of figure out what the mills were. So if that target was milling from here all the way to there, now it's a little bit easier to see that's probably closer to 0.7 right there. All right, so our eyes can break it up a little bit easier, all right? But as we go through and we start talking about the horse reticle in a minute, you're gonna see it's real easy to refine your milling to where you can very accurately get a range estimation. All right, the next reticle that we really kind of got into for a while, all right, was basically just a ballistic reticle. On ballistic reticles, you start out and you have 200 meter hold here, 300 here, a little bit further down, you go 4, 5, 6, 7, 8, and so on. Now, the thing about ballistic reticles, if you actually work with a ballistic reticle and it's made for your weapon system, your BC, it's kind of like a bullet drop compensator on your turret. You'd auto 200 for 2. All right, so you'd put the 2 for 200, 5 for 500. All right, they both have the same problem. The problem is this is set up, ballistic reticles and ballistic drop compensated turrets are all set up for 1 density altitude, 1 muzzle velocity, 1 BC. Unless you're hand loading and staying in your own environment and not changing bullets, if you don't, that's fine. It's a very accurate system. And if you're out here, you know, shooting in West Texas and it's using the same reticle and you're not going up to 8,000 foot hunting elk or something, this reticle works. But the problem with this reticle, the equivalent hold for this right here for 800 is 8.5 on the classroom gun that we've been running. All right, now if you jump up to 8,000 foot, your hold for 800 meters is really 7.5. All right, so this dot's gonna miss by a mil. All right, at that distance. You're looking at 26 inches for a miss. All right, so ballistic reticles really quit working after about 400. Now at 400 meters, you're only probably a half a minute off or so. All right, so it's still a good reticle out, you know, if you're hunting and you're not gonna take a shot past 400, that's where your limits are, that's what you set for yourself. Ballistic reticle is a good reticle. There's nothing wrong with the ballistic reticle. But after 400, you're gonna start seeing that separation. You know, last year we came in here and we was shooting training and I jumped up and went up to Colorado and shot an elk with my buddy. He borrowed my gun and he took a shot at an elk at 1,153 meters. He hit him with the first shot. We zeroed the gun here, trued it here, changed our atmospherics, went up there and hit the target. If we was using a ballistic reticle, it wouldn't have been even anywhere close, you know, even with the 338. So what you gotta understand is ballistic reticles, where they work and where they quit working. All right, so from 400 meters and down, not so much as you change altitude, all right? And that's another thing, most reticles are kind of set up at a average density altitude. You don't want to set one up for sea level and you don't want to set it up for 8,000 foot. They set it up in the middle to kind of cut their air in half both ways as they go up and down. The environment that some of our guys hunt in and the environment that our military boys fight in, you know, whether it's in Afghanistan or high up in other places, you can't utilize a ballistic reticle. It's not a system that will actually work.
Hey Todd, I'm gonna hold you for a second. I guess also you're not just talking about density altitude, but if you change that gun or that ammo or any other facet, that thing's getting affected at that point. I mean, that's just, you're just covering right now. If you went from, say, you know, Florida to up in the mountains, you're going to be affected. That same gun, same bullet, same hand load, same everything. But if you changed it round at that point, you're...
Oh, absolutely. What you're going to see is, you know, you could actually take a standard mil-dot reticle and put it on your 338, and you could pass it off and hand it to Mike and say, hey, try this on your M4, and he's good to go. It's a good system. It'll continue to work. But you take a ballistic reticle and your gun fell off this truck right now, now you have to find another 308 ballistic reticle shooting the same ammo. You can say, hey, let me borrow that 300 Win Mag, you know, let me take the scope off it and put it on this gun. It won't work, all right? So it's a huge point. A lot of times, you know, we like the capability to swap scopes from one system to another. I used to have people tell me all the time, man, I can't afford a Smith & Bender scope. They're kind of pricey. And I go, well, how many rifles do you have, you know, hunting rifles? And they go, oh, I've got 6 or 7, you know, in the house right now. And I said, how many scopes you got on them? They go, 6 or 7. And I go, okay, what'd you spend on your scopes? $400 to $800? And they go, yeah, I've got one cost $1,400. I said, what if you sold all your scopes, bought the best glass made to man right now, and then put it on a ring that you could actually take it off, move it from one weapon system to the other. Now you're shooting the best glass made, all right, and enjoying the full capability of your weapon system. And you try to tell people all the time, they'll go out and they'll spend $3,000 on a rifle and put a $400 scope on it. You know, if you're spending $3,000 on a rifle, it's really kind of smart to go ahead and spend $3,000 on a piece of glass, all right? The glass is actually more important than the gun is. Most weapon systems today, I mean, you can buy some really nice Tikka rifles, hunting rifles, you know, and they're not very expensive at all. You can get $500, $600 rifles. They're very accurate. They're minute of angle rifles. Put a $1,000 piece of glass and you're going to maximize the benefits of accuracy that you're going to get out of that weapon system. But if you take a $3,000 rifle, custom made by Tactical or Surgeon or any one of the great, you know, gunsmiths out there today, and they're making good weapon systems, and put a sorry piece of glass on it, you still got a 2 minute of angle gun as far as the effects that you're getting on target. you know, because it just changes. You know, if you're working with a really good piece of glass, you're going to maximize and get the benefits of whatever that weapon's capable of. And most of the guns are very capable that are made today for the hunting market, and as well as the tactical side, very accurate. But the big deal is we really need a good piece of glass. But let me show you something else that we was talking about a little bit earlier, all right, when we was going through second focal plane. All right, back to a mil dot reticle. If you're dealing with second focal plane reticles, in second focal plane, a good way for you to know if yours is second focal plane, when you look through it, all right, you've got your reticle and you've got your target. If you decrease your magnification, if your target shrinks in size but your reticle stays the same size, that's second focal plane. The problem with that is you can only mill at max power really effectively. But there's other things that we can do with it, all right? So if I go ahead and I actually zero here, and I turn down to half power, and again, you have to utilize the same thing because not all dials actually equal what they say they do. All right, so if we cut it down to half power, each one of these mil dots is now worth 2 mils. All right, so if I want to extend my range and I do the poor man's horse and I zero up here for 100 meters or 100 yards, all right, now this is zeroed at 5 mils, or the equivalent of 5 mils for range for whatever weapon system I'm working with, and this is equal to 10 mils. All right, same thing as we talked about a while ago. If I cut it down to half power, this now is 100 meters, all right? And then, what do we have here? This is still 5 mils, but this is worth 10 mils now. So I have a total of 15 mils that I can actually utilize. Again, we can continue to decrease, all right? So if you have a, let's say a 4 to 14 power scope, 7 power would be half power, right? But what if you was able to come all the way down? What if you divided 3 into 14? That would tell you what each mil dot's worth, all right? If you were down at 6 power, 6 into 14, that tells you what each mil dot is worth in mils, all right? So you can actually really start to push out your range with the current systems that you have right now. You don't have to run out and go buy, you know, a Smith & Bender scope with a Horus reticle. This is good knowledge. You know, it's a good way to utilize it because you never know what kind of weapon system or a scope or reticle that you're going to be running.
I think that's an interesting point you bring up, because in most instruction sets, people say you can only mill at full power. And if you really know that magnification ring and how to set that, effectively what you're saying is you can effectively mill a target at half and possibly quarter power.
Yeah, you can. The only real problem with doing that, though, is, for one, the target gets smaller.
Sure.
All right. And as that target gets smaller in a second focal plane scope, it's going to be harder to mill. When you're doing UKD shoots or unknown distance targets, the problem is that target, as small as the targets are that we shoot at, when you start backing out that magnification ring and you don't have much power to work with, it's very hard to mill that target at that size. But the biggest problem is the calibration of your actual dial, knowing exactly where half power is. So again, biggest points here are calibrating our reticles, making sure that everything is matching up with the dials. The other deal is, guys, when you're dialing turrets, you really need to make sure that you've actually calibrated and made sure that what that turret is turning is actually happening inside the scope, all right? So as you're turning that turret, you may dial 5 mils, but you may not be effectively getting 5 mils out of that turret. It's a man-made mechanical object. Sometimes they're not that great. And I've seen a lot of them that you dial 5, you get 4.5, especially when we start shooting out to the ranges, you know, that we're looking at. Now that was an extreme, is being a half mil off at 5 mils. But when you dial 20 mils, it's not uncommon to only have 19.5 actually being dialed onto that scope, or having 20.3 or something like that actually on the scope at that time. So another way, like we talked about the cat's target, it's a real cheap piece of paper, and you can actually, you know, use a ruler or something, a yardstick, and actually draw it off. You know, we talked about 100 meters or 100 yards. If you go 100 meters, you need to have 39.3 inches, you know, at 100 meters to have 10 mils, where you at 36 inches is what you need for 100 yards. All right, so if you take a ruler and you mark it off and you're exactly 100 yards, and you really have to be exact on that, but it'll equal 10 mils, and you can start calibrating and figuring out what your dial is, how much, you know, turrets that you actually have as far as how effective they are. And we'll actually show by shooting the cat's target that when we shoot at the little box on the bottom and then we actually dial 10 mils and shoot and it actually hits on the 10 mil line, or dial to 20 and it hits on the 20 mil line. You know, I tell the guys it's something like the old commercial used to say, you know, moose hunt, $7,000, flight to Alaska, 600, guide service, this, that, taxidermy, a calibrated scope is priceless. If you don't know what you're getting out of it, I was shooting in a competition one time and I wasn't real used to that scope. I was actually shooting a horse reticle in that manufactured scope, but the turret wasn't actually correct. So at 4 o'clock in the morning when we're shooting movers in this competition, it was real dimly lidded mover, was 500 meters back. I dialed up 3.5 mils, my hold for 500 meters, because I didn't want it to be in that bracket. I was real new to using the system. So I dialed 3.5 and missed a whole bunch of targets that night, all right? And couldn't understand why until I took my scope the next day and checked it, and 3.5 mils wasn't equivalent to 3.5 mils. But that's experience, Tried something, figured out from that point on, if you're ever gonna dial, you need to know exactly what that dial means on your scope. So if you dial 5 mils, know that it's 4.8, or know that it's 5.3, or know that it's 5 mils exactly. A lot of the scopes that are made today, good quality scopes, usually are pretty close, all right? But that doesn't mean all of them are. So it's something that we actually need to check, all right? So now, the next reticle that we're actually gonna go into is a horse reticle. All right, the horse reticle is basically subtended 0.2 mils all the way down left and right, all right? So, and it also, when I say left and right, it gives us wind as well. So if you look at what we're looking at here, you'll have lines. It's a gridded reticle, all right? Has 1 mil marks all the way up, and then it's subtended at 0.2 mils all the way across. Now initially, if you're like me, first time I looked at it, I said, oh man, that's too busy. I don't like it, all right? After the second day, I said, all right, I got it. I can see there's some major benefits here. I'm not dialing, I'm not leaving the wrong dope on, I'm always just doing holes. I can see if I can see my impact where I missed, very quickly I can do a second shot correction. I can meal much better utilizing this than the standard meal dots that I've used in the past. And so I started to get around it a little bit, but it was one of those things that I really didn't like it. I still thought it was a little bit too busy for me. The more I shot it, by day 3 and 4, when I woke up on morning 4, I was already trying to figure out a way to, get a good guy price on one, because I was already sold. Once you've actually utilized it, what you're gonna see is you actually look through the lines and find the target. All you utilize the lines for is a reference point as far as an aiming point to utilize for aiming. So when you actually look at the reticle, at first your eyes are focusing on the reticle. But once you start using it, you realize very quickly your eyes are focusing on the target, and then you just find the actual hold that you need to hold on the target, and that's the only part of the reticle that you actually see. A lot of people say, yeah, it's too busy, I can't use it for observation. There's many guys that do, all right? So that's already been debunked. I've heard you can't shoot movers, you can't shoot snaps, you can't, get lost in the veg, and none of it's valid. We've actually tried it. We can actually shoot anything that we want to shoot as far as reticles. If my son goes down range in a couple of years, this is the reticle that I want him to have because I know the benefits of it. I know what it'll do for him. You need about 4 days on the horse reticle to really get wrapped around it. I have a lot of guys that actually try it and then they put it up and they go, oh, it's too busy, I really didn't understand it. It's really just another meal-based system is all it is. There's nothing wazoo to it. You just don't have to dial anymore.
Well, that's the biggest problem with our society, specifically when we're talking military and when you get into special types of groups of people, A-type personalities, obviously. That's what we do. We look at it and we're like, it's too busy. We shoot it a couple times, like, nah, I'm used to what I'm used to. I'm not that comfort zone. And that comfort zone should be an alarm in our heads that go, hey, wake up, I need to think outside the box here. And that's what I've been doing, looking through this system now. Every time I look through it, I find if I look through it consistently and keep tracking that thing, it just gets easier and easier and easier. And it's just like anything else we do in life. Driving a vehicle, the first time you jumped in a truck when you were 15, 16 years old, were you comfortable? No, you were like, oh my God, you're trying to look for every little line and not hit any oncoming traffic, but now you're drinking coffee, texting, and driving with your knee at the same time. So it's like anything else, it'll come.
First time in a helicopter, you're kind of hanging on, don't know exactly what's going to happen. Is that pilot any good? Then the next time you're hanging out the side shooting at coyotes, it's that progression, and it's the same deal, it's comfort zone. So initially when we look at it, because we may not understand it, we don't want to give it a try. Because it's like, hey, I don't understand it, so I'm not going to be the guru on this anymore. But once you look at it, it's just a meal-based system. It's just refined so that now we can meal better. We have more reference, as far as aiming points. And there's nothing different. There's nothing wazoo. It's just a very basic reticle once you actually apply it.
It's common sense.
Absolutely. All right, guys, so as you can see, there's a lot of different reticles out there that we can utilize. The biggest point is don't get locked in that old school method. You know, expand your horizons, get out of your comfort zones, learn how to use the one that you have better, and look at what others have to offer. All right, so play with the PDA, look at the math, go through it, none of it's hard. Rewind the DVD 2 or 3 times and you'll figure this out really easy. This isn't rocket science, all right? So it's just very simple math as you go through it. Back to the basics, it's just the fundamentals. The more you understand the principles that apply in the math when you're looking at the reticles, the simpler it all gets. All right, guys, we got through with zero. We've came out to the range. Now we're actually going to get a range card, all right, or gather our dope. Dope was initially the data gathered on previous engagements. That's what dope means, all right? In the past, we would actually gather our dope by shooting at different ranges, starting out at 100, what we did previously, moving to 2, 3, 4, and so on. This would actually take a lot of time, and you'd write all the information down in a data book. And you'd carry that data book with you when you found yourself in a position that was somewhere like something you shot in the past. You would pull that information up and actually shoot the hole that you shot previously, that you got the actual impact that you were looking for. Well, nowadays it's a little bit different, all right? The Army ballistic computer and the ballistic solver that the Marine Corps went with is the A-Trag. It's from Horse Vision. Guys, this will work in mills, it'll work in MOA as far as your holes. The computer works in anything. It's not set to a Horse Vision scope. It can run off. We even teach people how to true their ballistic reticles, all right? In the military and law enforcement, even in the private sector and the hunters, they actually use sometimes a ACOG that is a ballistic reticle or other types of ballistic reticles, all right? But the PDA works with any kind of weapon system. But what you need to understand is it's a predictive polynomial curve. It's still just a close guess, a mathematical close guess, all right? So what we're gonna do is we're gonna actually go through the PDA. I'm gonna show you how to use it. We'll go step by step. If you have any questions, just blurt them out and we'll walk through them one by one. All right, what I want you to do first, I want you to actually go in and build a gun. So down bottom, low left, hit gun list. All right, once you've done that, hit add new gun. All right, then go ahead and name it whatever gun that you wanna name it. And a lot of times with a lot of the groups I work with, I want to name it your name, Mark 13, 191, whatever your ammo is. For the hunter or for whoever else, if you have different types of ammo, you might set up the same gun with different types of ammo. It may be Black Hills, maybe Ruag. If you're shooting the same stuff, you may have a different weight of the bullet, like a 175 or a 168, something like that. So you don't have to go in and change a lot of stuff each time you go into your PDA. You actually just get to go in, down select the gun and ammo combo that you're working in, pull it up, and you're ready to go. All right, now that you've actually named a gun, what I want you to do is go into gun list, select that box by that name, and hit open. All right. From there, what we're going to do is go to up at the top left, it says gun. All right, we're going to plug in all our gun data now. All right, what you're going to see is it's going to pull up a lot of gun information. All right, first is your bore height. All right, you can measure from center of bore to center of scope. All right, and when you do that, somewhere right at your turret. All right, it should be in the center of the bolt to the center of the actual turret on your scope. Now, if you don't have a micrometer or a ruler or something in the field, and we really try and work around doing stuff in the field as much as possible, all right? You can take your finger, and every line on your finger is real close to 1 inch, all right? And I'll show you that it really doesn't matter that much, even at long range, if you're 1/4 of an inch off on your bore height, all right? So once you've got your bore height plugged in, I want you to plug in your bullet weight, all right? Next, after you plug in your bullet weight, plug in your bullet diameter. Now, you're shooting a 30 cal bullet. Unless we're running 5.56, which we'd plug in .223. The next one down is C1 coefficient. All right, that's your ballistic coefficient of your bullet. All right, back in the 1800s, Charles Cupp came up with the way that we actually define what a bullet is as far as the numerical value that we put on it. All right, so he shot a 1 inch diameter bullet, all right, that weighed 1 pound. And when he shot it out, he deemed whatever the actual performance that bullet actually gave him, he deemed that to be a 1 BC, all right? He made another bullet, deemed it to be a 0.5 BC. From that, it's the same way that we look at girls and go, wow, she's a 10, she's a 6. It's the same thing that we're doing with a bullet, all right? But we're just putting a numerical value on it, all right? So really what you're doing now, you're trying to define how efficient that bullet is in flight, all right? How well it will fight through wind, how well it will maintain velocity. That's what we're looking for. So the 175 grain bullets, go ahead and plug in 0.47. And we'll quantify this a little bit. A lot of the data that you're going to see, the 175 Sierra, they say it is a 0.496. All right, that's based off of a G1 scale. All right, so we need to talk about G1s and G7 scales. A G1 scale is a higher lenticular curve based off of a bullet that is not as efficient in flight. All right, so with all the math that it has from muzzle velocity and weight and efficiency of the bullet being the BC, it's going to have a higher arc, all right, a higher lenticular curve. Then you have a G7, which is something like you'd use for a VLD bullet, which is a lower lenticular curve or a more shallow lenticular curve. All right, well, if you look at it, really, the ATRAG ballistic solver doesn't run off either. All right, it's a morphed G1, G7 that was actually developed by Bill Davis with all the data that he built shooting through Dopplers. All right, this is actual flight data of the bullet itself. All right, so he took that data, compiled it, Horus Vision bought it, and actually stuck it in a ballistic solver. So we're not really in a G1 or a G7. That's why a true G1 may be somewhere closer to a 496. I'm not going to argue that point. All right, but what we've actually found is the actual G1 is closer to a 0.47. We've actually shot at 1,000 yards, thousands of bullets, and actually tracked, shooting through 3 chronographs all at the same time to where we had a good close guess. All right, you really need a calibrated chronograph to do this. All right, but based off the actual impact of the bullet, it can tell you your actual BC if you know the velocity. The problem with this, ballistic solvers are predictive, all right, meaning that they're giving you a mathematical guess. Well, if you have a BC that's slightly off, all right, it's going to actually, and you shoot through a chronograph that's even calibrated, but it's actually not a real BC, your ballistic solver is not going to give you accurate data, all right, because you have bad information. It's just a computer. You put in bad information, it's going to spit out bad information. So what we did, we went in and changed it. We have a truing option, which we'll get to in a minute, but I'm going to explain a little bit of why we use a truing option. All right, if we don't know, or we're just getting close to an actual BC for that bullet, all right, and we find out where the bullet actually hit downrange, somewhere around the start of transonic flight, all right, and the reason we do it at that range is if you do it anywhere any closer, you can't see the separation in the algorithm. But the further we go out in clean air meaning there's not transonic shock waves affecting the flight path of the bullet, the further we go out, we see more separation in the algorithm, so we can actually refine it a little bit more. All right, so basically what we do, we tell the PDA where the bullet actually hit. By doing that, we're truing the actual data that the PDA is spitting back out at us. All right, so that's a little quick lesson on BCs and how we actually use them. We'll teach you a little bit later how you can actually go in and figure out the actual BC of your bullet by truing your BC. All right, now, next we'll go into rifle twists. All right, when we started looking at rifle twists, basically guys, your 308s that we're running today, most of them are all around 11 twists. All right, the 300 should be somewhere around a 10 twist. That means there's 1 rotation in 10 inches of barrel, all right, or 1 rotation in 11 inches of barrel. So if we have a 15 twist, it actually takes longer, so it's actually a slower twist to get that full revolution. All right, so you actually need to know what your twist rate is of your rifle. It's actually going to give you spin drift. So even with a no wind environment, shooting at distance, your bullet will track off with a right hand twist in the direction of your twist, which would be right. All right, so shooting at 2,000 meters, you know, you say, well, how much does it really matter? All right, shooting out to 1 grand, it's really not that much. All right, but shooting out to 2 grand, you can have 40 inches of spin drift nearly, all right, at 2 grand in 0 wind that you have to account for. All right, so we'll get back into that a little bit later when we start, and I'll show you on the guns how much there actually is. All right, so next we have muzzle velocity. All right, we've talked through a little bit today. The different barrel lengths are going to determine muzzle velocity a little bit, but we're actually going to find our muzzle velocity. All right, the way that we do that is through truing. So we'll go get set up on the weapons here in a minute. We'll lay down, we'll find the exact range. All right, in doing that, we're actually going to use the laser rangefinder. We do not meal the target trying to estimate range, because if we don't do a really good job estimating the range, we're basically gathering data off of bad information. All right, so we laser the target, we know exact range, you plug the exact range in, and from that point, then we can actually find the actual real muzzle velocity that that bullet is flying on because of where it hit. We already know the BC, we're going to have the correct density altitude plugged into the computer. The only other option is actual muzzle velocity. And wherever the bullet hit, it tells us the muzzle velocity. We're not making up anything on our own. We're actually tracking where the bullet hit, and the bullet tells us what the formula needs to be. All right, so once everybody's got through with that screen, your zero range is at 100 meters from this morning. All right, next screen is atmosphere in the middle column. Go ahead and hit on it. All right, you're gonna see AT and TBH up at the top. AT is altitude and temperature. TBH is temperature, barometric pressure, and humidity. All right, I like to run on the temperature, barometric pressure, and humidity because it gives a closer resemblance to what the bullet is actually flying through, all right, on how dense the area is. Temperature and altitude gets us close, but we're at 2,700 foot right now, and within a couple of inches until the end of time, we're gonna be at 2,700 foot. But because of cold fronts and warm fronts that come through the area, the bullet may think that it's 400 or 500 feet higher or lower than that because how dense the area is at that time. So if you use barometric pressure, all right, you're going to get a closer resemblance to actual denseness of the air with temperature, barometric pressure, and humidity. And humidity doesn't play a huge role, and I'll show you in a minute how much it actually plays. All right, most of the time we keep our humidity at 50%. All right, that's pretty much across the board. You can plug in the exact number if you want to, but I'll show you here in just a minute. We'll make a full swing. You'll see how much actual change there really is. All right, target, you go ahead and hit it. All right, you're gonna see latitude and direction of fire in the first two columns. All right, what that is giving us is actual Coriolis. All right, Coriolis is while the bullet is in flight, all right, if you're shooting it at a long enough distance that it has a long enough time of flight, the rotation of the earth, all right, what you thought you were aiming at has actually moved and moved around the rotation of the earth. So if you're aiming at the top of this target, if it has a long enough time of flight, it's moving around the curvature of the earth and you're actually shooting due east, you're gonna hit high. At 2,000 meters, you'll hit close to 20 inches high. Obviously, shooting to the west is just opposite, all right? It's moving to the east, so your bullet is actually gonna hit low. You were aiming at the head, but it actually moved up. The perception of where you aimed, your bullet's gonna hit that at that spot, but the target actually moved up around the curvature of the earth, all right? So, wind speed, all right? Wind speed, there's two blocks now, all right? There's wind 1 and wind 2. Obviously, wind doesn't always blow 6 miles an hour, all right? So what we did, we went in and plugged in where we could say, hey, wind's gusting today from 8 to 10 miles an hour, so you can plug in 8 and 10, and you don't have to wait for a medium wind to shoot in, all right? It may have spit out, hey, wind's from 6 to 10 today, and you plug in an 8-mile-an-hour wind initially, and so you're having to shoot in the medium wind. Now I know my holes for a 6, I know my holes for a 10, I can extrapolate between those holes at any wind speed anywhere in between. All right, so we're making a more knowledgeable shot at all times. All right, underneath that you have wind direction. This is in clock positions, all right? So based off the line that you're shooting at towards your target, 3 o'clock's gonna be due right, all right? 9 o'clock's straight to your left, all right? Obviously, based off that, it's gonna give you a cosine of the wind and the actual value of it. All right, inclination angle, you have C and D. All right, C it says 1 right now and D 0. All right, that means that if we were shooting at 800 meters, you have a full 800 meters, all right, that you're shooting as far as how much your bullet's gonna be affected by inclination. All right, so if you actually plugged in 60 degrees, you're gonna see that the C is actually gonna turn into 50%. All right, so that's what this is. Depending on which inclinometer that you're actually running, you may actually have something that says, hey, I have 30 degrees right now, or you may have something that says 71 or 87, whatever your cosine is, all right, for whatever degrees that you're actually looking at. So that you can plug in either or and it will change the other one for you. Next line down, target speed. All right, you can plug in the movement of your target as you're looking at it. We can refine this and do this several different ways, but that's what this is for. If the target's moving 2 miles an hour, you plug in 2 there. All right, if you go and look at target range right now, go ahead and plug in 800 and hit done. All right, we'll get back to target speed in a minute and I'll show you a quick way to actually find the actual speed of the target that you're looking at. I told you to plug in 50% humidity. All right, Travis, I want you to go under atmosphere and change yours to 10% humidity and tell me your hold.
8.67.
All right, 867, change it to 100% humidity.
861.
all right, difference of 0.06 mils, all right. 0.3 mils is real close to a minute of angle. It's 1.08 inches at 100 yards. All right, so what you're going to look at is 0.06. 0.1 is a third of that, right? 0.06 is nearly half of that. So you're looking at a sixth of a minute of angle in a full spectrum of humidity. All right, 0.06, we can't hold it. We hope that we can run somewhere around a quarter minute. All right, a quarter minute would be awesome if we can hold a quarter minute. All right, most of the guns and ammo combinations that we work with are somewhere closer between a quarter and a half. Hopefully, you know, still half inch is really, really good. All right, so when you're looking at a sixth of a minute of angle, this isn't something that we really worry about. So by plugging in 50%, what does that do? Cuts that air in half, and now we're only dealing with 0.03 mils, all right, which turns into a 1/12 of a minute of angle. All right, so it's in either direction. So it really doesn't matter that much.
So getting wrapped around humidity, which I hear a lot of people doing, talking and talk, it's not worth it.
Yeah, it's really not. All right, if you're shooting out at extended ranges, and I'm talking 1,500 meters with a 308, then I might want to go ahead and actually plug in the actual humidity. But you're going to see once you start testing and playing with it, even at that, it's not going to be that much off. You know, you're going to have a lot more problems come up that you can't assess whether it was from the humidity or not. All right, shooting at those kind of ranges, or shooting out to 2 grand with the 338 Lapua, something like that. It's not bad to actually plug in the actual data, whatever the actual data is, but you ain't got to get wrapped up on it out to 1 grand, you know, what we're going to be shooting today. All right, so everybody's looked at gun, atmosphere, and target. Then you have truing drop. Now that's what really sets us apart from most of the crowd. The truing drop information is what we talked about earlier. That's what we're fixing to go do. Guys, we can take, after we've zeroed, all right, from that point, we move out, and within 1 round, we can actually get a good true. All right, Jason St. John and Robbie Johnson, a couple of shooters that I know from down at Benning, they were shooting in a sniper comp, and we actually sat down and did a quick demo with them. At 795 meters out, I told them to shoot at a target after they zeroed a gun they'd never shot before with ammo that they'd never shot before. They zeroed the gun, got a good quick zero, turned around and shot at 795. I gave them an errant muzzle velocity. I told them it was too fast. I knew that ammo wouldn't be running that fast, but I knew we could see the miss and see where it hit. All right, based off that one miss, we gave him a second shot correction, which hit center, plugged the information into the PDA. So from that one miss, we had our algorithm. We had a pure range card. All right, now from that, he engaged targets from 300 all the way out to 1,000, never missed high or low over 4 inches all the way out. All right, so.
Like you said, this does set you apart from the crowd. And how did you come up with this concept of truing?
You know, it was what I call cowboy math. I grew up in West Texas. You know, it was common sense approach to everything, ranching and farming. So instead of being a ballistician, all right, and I know that to be more refined, if I had a calibrated chronograph and I really knew the actual BC of the bullet, and that becomes another issue because bullet companies sell bullets by BCs and basically the terminal effects of the bullet that it has on target, all right? So if you're a target shooter or a paper puncher, you want a good high BC, something that's gonna fight wind well and fly good, all right? If you're hunting or doing something else like that, obviously you have to have both. You know, you have to have one or the other. You may have to give up a little bit here, get a little bit, you know, somewhere else, but basically you want it to do damage on tissue so you can have a good, quick, clean kill when you're out hunting. All right, so when I was looking at that, I noticed that my BCs always didn't match up with what the company said they did. All right, and like I told you earlier, the way I actually find my BCs, and I called Ken Ayler, the guy that makes the Ayler chronograph, and asked him if what I was doing was correct, and he said, absolutely, we're gathering actual data that way. It's an actual BC. And I've talked with Brian Litz. All right, he's a ballistician for Berger, and he absolutely agrees that what we're doing is correct. If you have a calibrated chronograph, all right, and if you know the actual BC of your bullet, then you don't have to true. All right, it's going to give you a good algorithm, and it's going to be a pure algorithm. But the problem is laymen, we don't have access to Dopplers. All right, if you got a Doppler in your backyard, go use it. All right, it'll give you good data. Most of us ain't got one. All right, so what we have to do, based on where the bullet hit, I didn't want to read off PDA because PDA actually gave me errant data. If you're wanting to do headshots at 800, a lot of times if you just go off what the PDA said, you were going to miss. So basically what I did, I said, hey, this is a page that I want. This is what I want it to say. When I shoot, wherever the bullet hits, I want to plug that in and tell the PDA to change all the math to match where that bullet just hit. All right, so minimal starts about, with a 308 today, about 600 meters. That's minimal. All right, up to transonic. Now transonic is right at, in my opinion, about 1,340. I know it's a little bit pre-subsonic, but depending upon density altitude, I don't want to get into transonic flight. All right, so 1,340 feet per second is getting close to transonic. All right, and so that's what we're working off of. All right, so you're going to look at your range card here in a minute. You're going to change your last column to remaining velocity, and you're starting to scroll down until you see 1,340. So go ahead and do that now. Hop into range card up at the top right. All right, once you plug that in, down at the bottom it says last column on the bottom left. Last column, make it read remaining velocity. And you may need to change your setup to 5 meter increment. All right, you can start it at 100, in range being somewhere around 2,000.
1343, that's what I got.
Yeah, that's close. That's good enough. So what range is that at?
810.
810. We need to find a target out here somewhere close to 810. All right, and then we'll actually take a shot on it. And if we're shooting 5.56, 300 Win Mag, all right, the closer you get to transonic, the more pure your algorithm is going to be for what we have access to. Like I said earlier, if it's a calibrated chronograph into the known BC, it's going to give you good data.
So 1340 is that magic number then for any caliber?
Yeah, because it's speed of sound. Yeah, 1,061 plus temperature of the day gives you a close speed of sound, all right, converted to feet per second. So if today's, 70 degrees, all right, 70 plus 1,061, all right, it's 1,131. All right, that would be the speed of sound today. And it's not perfect, but it's within a couple of feet per second. All right, so it's good enough for what we're doing. All right, so the 1340 is pre-transonic flight. All right, what we don't want to do is actually run out and try and true a 308 at 400 meters, because at 400 meters, I can be a minute of angle off. All right, I can be doing headshots on an 8-inch plate at 400. All right, when I do that, the top of my cone, all right, the top of my dispersion on my 1-inch group is in the center of the target. All right, the bottom of it is nearly at the bottom of the plate. I'm calling that, hey, that's just me, that's just me. I'm hitting center, and then you hit one that's a little low, and you want to blame it on yourself. No, you still remember all the good things that happen in life. So you're saying you think you're good. You may actually adjust it up and move it, but the problem is the difference in a minute of angle at 400 is 120 feet per second. All right, once you move out to 800 meters, that same change is going to be over a mil. All right, so you can't assume what your muzzle velocity is by truing at 400. You need to stretch the algorithm out to see the actual dispersion, all right, and see the difference in where the predictive algorithm is and the actual algorithm is.
So we want to miss by a mile, not by an inch.
Yeah. Any more questions? All right, if no more questions, grab your stuff. Let's go over to the guns and we'll actually sit down and true. All right, guys, now what I want you to think about is your scope has to be exactly level. All right, it's very important. We really push putting bubbles on the scopes, all right, because if you can't as much as 2.5 degrees, which seems to be really hard for people to actually see that they're canted that much. Obviously, looking out here, we're not on a golf course range. This is a real world range, has lots of curves, lots of hills. It's real hard to depict what is level. All right, so having a scope level is real important. If you're 2.5 degrees off, you're going to hit 0.1 of a mil every 100 meters in the direction of your can of your scope. All right, so if you're 5 degrees off at 800, you're going to be 0.8 mils in the direction of the can of the scope. So really work hard at leveling the scope, making sure it's as level as possible. All right, Travis, pull up your PDA, go to range card, find 1340 under remaining velocity, and tell me what range that is. And y'all remember, this is what we call pre-transonic flight, the transitional period to where the bullet's going from supersonic into subsonic flight. All right, we want to go right up to the edge of it, all right, right before we go into transonic flight.
795.
795, all right? Look out to the left, all right? There's 2 targets on the left side of the range. Go ahead and hit the closer one.
That's 797 at the
All right, that'll work.
So that's perfect.
And it really doesn't matter. You can be plus or minus, 50 meters on this thing. You're going to be okay, all right? But you really want to be somewhere around that range. Like we said earlier, if I had to, I could do this at 600 with this weapon system, but it's going to give me a cleaner algorithm, a more pure algorithm the further I can go out pre-transonic, all right?
Speaking of the level, it's funny because this particular target where it's at, the horizon looks straight out there, so I naturally want to put my reticle on the horizon, but when I look at the gun level, it's not level at all, so it's something that people need to really think about.
Yeah, and a lot of times as you look at the target down over the top of the scope, if you level your top turret,
Yeah.
all right, it's going to give you a closer guess than just looking through your reticle. All right, a lot of times out here to mess with the guys for training purposes, as you notice, we hang the targets a little off-centered, all right, to where they're not straight up and down. All right, that's on purpose. And guys, remember, it's real important. We've already plugged in the current atmospherics, all right, barometric pressure, temperature, all right, and humidity at 50%. But we've actually already plugged all this information in. It's very important that this is actual, not a guess. All right, so go ahead and get it good and level. What does it say for 797 meters? What does your PDA say?
8.78.
8.78, your hold, right?
Right.
So go ahead and give me 8.8 in the center of the body on that target. Go ahead and hold left edge. All right, elevation actually looked really good. You were probably belly button height, but your impact was close to 0.7 to the right of where we were holding. So go ahead and hold 0.7 left. And guys, we really don't care. Doesn't even matter if you hit a plate. A lot of times I like to really refine guys on small rocks out at this distance because we can actually see, we don't get caught up. You don't want to just hit steel. If the steel's beat up and you hit steel and you're going, yeah, but I'm hitting the target, you may be a minute of angle low. You may be around 0.3 mils off, 0.4 mils off, still hitting steel, and incur bad data for your algorithm. All right, so go ahead and hold 0.7 left, send it again. All right, it was just off the right edge, nearly center for height, so we did a good job estimating the actual muzzle velocity of the weapon system. So go ahead and give me 1 mil left. Good, it's a nice hit. All right, you hit just under the lower chin. Send one more to confirm. All right, it's a headshot. All right, so you're holding center body?
Center body.
All right, from that, I want you to mill it and tell me how high you're actually hitting above where you're holding. You're about 0.3 high, correct?
I am.
All right, and you were holding 8.8?
My impact is 0.8 high.
0.8 above where you're holding?
2, 4, 6.
Tell you what,
no, it's
the
6,
average hit's about 0.3 up, so you were holding 8.8. Give me 8.5, center of the target.
8.5.
And all you have to do, guys, is just place the 8.8 where you're holding and look at where it was hitting on your reticle. Center body, left edge. All right, so now what you do is you go to your home page, go to options in the bottom left. Once you pull up that, you're going to go to truing drop halfway down that pop-up screen.
Okay.
Under the range, you're going to see a drop of 8.8 in a white column. Change that to 8.5. All right, hit calc on the top right.
Got it.
All right, and then hit use MV, and then hit accept. All right, once you've done that,
okay,
look under your gun information. What is your muzzle velocity?
25.75.
All right, good deal. All right, now, Travis, what you're going to want to do now is go into gun list, select the gun you're working in, and save your gun so you don't lose all that good data. And guys, really, it's just that easy to actually find your data book or your dope. All right, perfect dope, and we could have done him in one shot. All right, he actually hit off the right side. All right, then he hit the target consistently, just barely high. We actually told the PDA where his bullet was hitting, and now he has an actual algorithm. All right, so once you save that gun data, you're good. And that would be good information to actually write into your actual data book now, is what the muzzle velocity was on this lot of ammo. Once you shoot out to that distance, you want to come back in and confirm at a medium range, because if you did anything wrong with your data for atmospherics or gun data, you're going to have an error in your algorithm and you won't hit where you're holding. Now, what we're going to do real fast to verify, you see the target that's about 400 meters out, the one just underneath the heel?
Yep.
All right, range that target.
405.
405. Plug in 405.
.5.
2.5. Go ahead and give me 2.5 on the target and hold 0.4 left. This is just confirming that we really do have a good algorithm, guys. Give me 0.4 wind, which is left edge. 2.5 center body. Fire when ready. All right, center hit. Good job. All right, Chris, you're up. You're going to do the same thing. So you're going to plug in 797 into your PDA for target range.
I've got 8.7 is what mine's saying.
All right, give me 8.7. You're shooting 308, correct?
Correct.
All right, go ahead and give me 0.7 left. All right, just off left side elevation was good. Give me a center wind. Nice hit. You hit right on Travis's bullet on the left side. Go ahead and hold right edge. Give me another shot. Just up above on his left shoulder, just probably 4 inches under his left shoulder. It's still well within half minute of angle on the target. That's good, both shots. All right, so we know we have a good algorithm. Go back in, make sure you save the gun. All right, Mike, same deal. All right, just give me center wind.
8.78.
All right, so you'd hold 8.8. You just round that last number up. Headshot. All right, you were holding center body?
I was.
All right, go ahead and give me another shot. We'll confirm. All right, we'll stay with 0.5 right. Headshot again. All right, so from where you're aiming, look in mils, how far it is to where your bullet is hitting. Looks like about 0.4, correct?
That's what I'm getting to.
All right, so you dialed on 8.8, so take 0.4 off, come to 8.4. All right, go ahead and give me another headshot. Aim with your crosshair on his head now. Good shot. Another headshot. Stacked all your bullets right there together. For your 300 win, we're going to push this out to 1,038.
Well, Todd, I found that really interesting. I mean, just conducting a test, just expanding on the zero at a range we once thought of as the maximum effective range for the weapon system.
You know, it really is. Used to, it'd take, you know, a couple of hundred rounds to actually lay down and shoot at 200 and 300 and 400. And at that time, you're actually incurring human error into your dope book, right? So while you're gathering your dope, you're actually incurring all the errors that we put into it. So what we're trying to do is actually just take out the human error as much as possible, gather the data at the maximum range pre-transonic, and then once you do that, you have a perfect algorithm all the way back. And really, you did 3 headshots at 800 meters, all right? Which a 308 used to, they thought that was the maximum range. We'll push that gun out to a mile, and you'll stay on that same 16-inch plate at a mile.
I'm looking forward to it.
Yeah, it is amazing. It's interesting, but you know, it's a deal. It's not hard. You know, in a lot of schools, they used to teach that 800 was kind of give or take. You know, you'd hit some, you'd miss some, and obviously as wind increases, it's going to get hard to call wind. You know, the reason we come to West Texas for training is wind is constantly, 15 to 20 miles an hour every day. We've been real lucky, today the wind wasn't really blowing that much, but it's still tricky because of all the terrain features. Wind changed left and right. Nearly every time somebody got up is a different wind for them, so the winds out here every 5 miles an hour, you lose about a 10% hit probability. It sounds like a lot initially, but you're 4 really good shooters. But I promise you, if you lay down tomorrow morning and you say, okay, there's a target at 800, you have a perfect dope book now. You have a perfect, range. You lay down, take a shot. If the wind's blowing 23 miles an hour, I promise you, you're gonna have about 6 out of 10 guys be able to make the shot and hit and connect past 600, by calling their own wind, making their own judgment, and making that shot. So that's why we come out here. It's not hard, and you can do it very fast.
And like you said earlier, the greatest thing about this concept is the minimal amount of ammo. I mean, like you said, Mike just made 3 headshots right after he just got done zeroing. And we did that at 800 yards, and we confirmed at 405. So we just saved a lot of time, money, and effort, where normally we would do exactly that. 100, 200, 300, 400, 5, 6, 7, 8, 9, 10, and how many rounds and how much human error is going into that with body position and all other stuff. That's a really great point.
Yeah, absolutely. And you brought up something good. That zero is very important. If you have a bad zero, guess what's going to happen?
Everything
when you shoot
else
out at
magnifies.
range, you've got bad data now. So you may hit. You'll be perfect at 800 because your bullet just hit there. But those interim ranges, that's why we went back and checked at 4. If you had a bad zero, it's going to start showing up at that distance. So,
well, the other part was the fact that you said the bullet doesn't lie, because when Travis first shot, he had to make some adjustments based on some speed. And the fact is, you can argue that all day long, or you can enter in the correct data of what it actually is, and therefore really true to the gun and the bullet and everything.
It's really interesting. The truing deal is really scientific. Even though it's kind of a cowboy method of getting, it's kind of like doing the backwards math, to getting your data. But it's very scientific in that that's where your bullet just hit. Why would you want to argue with your bullet? So if that bullet doesn't get to vote, once it leaves that barrel, it's going to have the same drop due to gravity every time that it goes out. So if you have the correct density altitude, if you have the correct BC, the correct muzzle velocity, it's going to hit at the same point. We may not know the exact BC, the reality of it. We may not know the exact muzzle velocity, but as long as we get really close on our BC, all right, go off of, the factory specs of that bullet, all right, and true, if you actually go off the factory spec of the bullet and it's slightly off, and guys, I have 2 good chronographs, and we interlink them and shoot through both of them at the same time. And they're high dollar chronographs, and they're 20 feet per second different than each other. All right, so that 20 feet per second at that target distance is a miss. All right, so we can't go off that. He couldn't have made 3 headshots if he was 20 feet per second off. All right, so what you really got to do is accept that even though you may be a little bit low on your BC, your muzzle velocity is going to actually be a little bit higher in the PDA than what may be reality on a calibrated chronograph. But it doesn't matter because the algorithm is going to be correct. Right? You may be slightly off, but it's going to be less than what the minute of angle of what you can shoot and what the gun can hold. Right? So it's still a very accurate algorithm to actually use.
All right, so what's next?
What's next is we'll actually learn to use a PDA. All right, so we're going to range targets, plug the information in, go from 300 meters all the way out to 1,200 meters. And with the big guns, we'll actually even push out further. Then after everybody feels comfortable and they understand how to use everything, we'll even go further than that. We'll push out to a mile.
Well, that's certainly going to be interesting going out to a mile with 308.
Everybody does it. Everybody in the class hits a 16-inch wide target at a mile.
Well, let's do it.
All right, let's go.